All right, number 2 on the quiz from Thursday.
Yes.
How many values of C satisfy the mean value theorem for g of x equals x minus cosine 2x on the interval 0 to 2 pi?
Yes, that's.
So, mean value theorem. Let's think. If two things are true, then algebra slope equals calculus slope.
Continuous and differentiable.
Continuous and differentiable. That's fine. Algebra slope equals calculus slope.
Yes.
Somewhere on the interval. But the endpoints aren't eligible, so we have to throw those out if that comes up.
Yes.
So, x minus cosine 2x. Well, x is definitely continuous and differentiable. Nothing crazy about that. Cosine 2x is continuous and differentiable. And so if you add or subtract continuous and differentiable functions, you still get continuous and differentiable functions. So, g of x is continuous and differentiable. And so that means that the algebra slope equals the calculus slope somewhere. So g prime at c, and c is what we're trying to find, is equal to the algebra slope. So there's a couple pieces going on. I got to find all the algebra pieces, do that correctly, and then I got to take a derivative correctly, set it equal to my correct algebra slope, and do the algebra from there correctly. So there's a lot of stuff going on, that places to make mistakes. So let's start with the algebra side of things. G of pi minus cosine of 2 pi. So let's see, cosine of 2 pi is 1. And g of 0 minus cosine of 0 would be negative 1. So my algebra slope, I'm just going to abbreviate it with m because that's what we use in algebra for slope, is pi minus 1 minus negative 1, lots of minuses going on, over pi minus 0. So I end up with algebra slope equals 1.
Yes.
Did we make it that far? Okay. I think I saw a few that had algebra slope equals negative 1. Well, then you're off already. And if you did that, you would earn my new stamp. Calculus is easy, algebra's hard.
Nice.
Isn't that awesome? They're both hard. That's fair. Okay, so I got this side is equal to 1. Now I need to worry about the derivative of g. So the derivative of g, derivative of x is 1. Derivative of cosine is positive sine of 2x times chain rule times 2.
Wouldn't you still subtract sine?
Well, there's a minus sign there, but the derivative of cosine is negative.
Oh, it is negative. Oh, yeah, that's right.
So the two negatives make a positive. So 1 plus 2 sine 2x. Okay, so calculus slope. 1 plus 2 sine 2x equals algebra slope, which is 1. So there's now my equation that I need to solve.
Yes.
Okay, so I'm going to subtract the 1 over. That gets me to 0. I'll divide by 2. That keeps me at 0. So sine of 2x equals 0. Make it that far?
Yes.
Some of you? Some yes, some no.
My brain is
So
just
sine of
checking
2x equals 0. Okay, so where does sine equal 0?
pi over 2
There and there. 0 and pi.
Yeah.
But that means I need 2x to be 0 and pi, and since I've got this 2 on there, 2 pi and 3 pi and 4 pi and all the multiples of pi. Now, I'm going to have to throw some of those out because I'm only allowed to look between 0 and pi. If I divide everybody by 2 to get x by itself, I get 0, pi over 2, pi, 3 pi over 2, 2 pi, and by then I realize, wait a minute, I'm way outside of 0 to pi. So 3 pi over 2 and 2 pi are definitely out. They're way outside. They're out for sure.
And then there's the endpoints that aren't eligible.
And then, yeah, the endpoints are not eligible, so they're out. And so that only leaves pi over 2. One answer. Okay, so there was a lot going on. Some basic algebra stuff, but you need a trig to do it. Calculus, which had a trig rule and a chain rule. And then some calculus solving stuff that you haven't done in a while. All that to say, there was one place on the interval that satisfies the mean value theorem. And you're guaranteed for there to be at least one. So if you meet the conditions, as soon as you say it's continuous and differentiable, it's definitely not none. If it's continuous and differentiable, it's at least one. After that, it takes some work to figure it out. All right. Most of you looked good on number 1 and number 3, the little bit that I saw, or the few that I looked at and scanned through. What I was mainly looking for in number 3 is you saying it's continuous and differentiable. And then something about calculus slope equals algebra slope, which I saw on almost all of them. All right, how about on the back?
4.
I had to redo number 6 because I messed up on number 6.
Okay, so what are the answers for all of them?
I am 99.5% sure that it's CCAC on the back. On the back. On the front was AB. And then CCAC. So which one on the back would you like? When did you say number 4? Okay, the function is given by this thing, which of the following is true? And it's asking me about increasing and decreasing stuff. So what tells me increasing, decreasing? First derivative. Second derivative tells me concavity. First derivative tells me increasing, decreasing. So let's do the first derivative and then we'll go from there. So 3x squared plus 12 is my first derivative. Okay, I'd like to set that equal to 0 so I can do the number line and do some intervals and test and see what's going on. The trouble is, if I set it equal to 0, it's never going to be 0. I mean, I can move some things around a little bit, but x squared equals negative 4. X squared equals negative 4, that's never going to work. I mean, you can use i's, but I don't have i's on my number line, so there's no real solutions. So f prime is never equal to 0. That must mean it's always doing the same thing. It's either always positive or always negative. So 3x squared plus 12, what kind of number is that always going to be? Positive. You square something, positive, add 12, more positive. So if f prime is always positive, that means f is always increasing. F is always increasing. There we go. I mean, you didn't have a calculator, but if you did, you could have checked, and you would have seen that, I'm assuming we're going to see that this is always increasing.
If we don't,
If we don't, we did something wrong.
Okay, yes, it's increasing very quickly.
See if we can see a better picture of it. Well, not really.
Go zoom.
Zoom out, zoom out, zoom out. But it's always increasing. Number 5 was a little more straightforward, where you ended up with a number line, -3 and 1, and it was increasing, decreasing, increasing. So you could answer from there. My problem with number 6 is I didn't see that that was f prime, and so I took off saying that's f and that's g, and g f prime minus f g prime. But all of that would have gotten me the second derivative. And so I found concavity stuff, but that's because I wasn't paying attention that they gave you f prime.
You fell for your own trick.
I did. So the only 0, well, the bottom would never be 0 because squared plus 1 is positive, squared is more positive. The only 0 would be x equals 0. So then I just need to check something on either side of 0. I plug in -1, I get positive. And if f prime is positive, then f is increasing. If I plug in 1, I get negative. Whoops, f prime is negative, which means f is decreasing. And it wanted to know where is it decreasing from 0 to infinity, which is what most of you did. And then 7 was really similar to 1 on the worksheet. Like, it looks terrible, but it's already has given you the second derivative. Okay, I bolded it and italicized it to try to prevent you from making the mistake that I made on number 6. And even then, you don't even really have to do a number line because that's a double root, that's a double root. So it'll change at 0, it'll change at -3, and it'll change at 1.
Yay.
So 3. Questions on any of those?